Well, hello everyone. So we are back here with a new program starting from today with this video. We will start structural analysis. Okay. This program will be divided in at least 3 main parts. Okay. This part is structural analysis 1, static. We will talk about maybe just introduction of a structural analysis. Okay. So this first part will be followed by at least 2 more part of this structural analysis. Okay, so I hope we will be able to learn something together. Here is the content of this first part of this program. Okay, so we will do 5 chapters. The first chapter, the one we will start today, is about just general things, static, and about material resistance. The second chapter, chapter number 2, we will be about mechanical actions and balance of non-deformable structures, bodies. So mechanical action include forces, moment. Okay. Chapter 3 will be about connections and support reactions, internal stresses of isostatic structures. Chapter number 4 will be about geometric and mechanical characteristic of sections. The last chapter of this part will be about normal force. So, and how to apply it to reticulated system. So this is the chapter of this first part of this program. And in this video, we will start with this chapter 1, of course. So chapter 1, which is general static material resistance. The content of the chapter 1 is here. So we will have 7 points: introduction, definition, deformation of structure, deformation of body, Hooke's law, Poisson ratio, and structural study. And we will do just few exercises. Okay, so today's video will be only about the introduction. Okay, this introduction is about general things about structural analysis, and we will have another video in this chapter that will include all the remaining points. Okay, so this introduction is maybe will be same length as the other point cumulated. So it will be about same length of video. Okay, so let's start with this introduction today, which is about just generally speaking, what is a structural analysis. So in this introduction, we will talk about a lot of things. For example, the structural analysis, where or in which domain do we use structural analysis? Some people might think that it's only in civil engineering, but actually no. We can use it in construction, civil engineering or building. in mechanics, okay? Machine, engine, and plane can be used also. It used also in chemistry. It's used also in electricity, cable, pylon power stations, physics, solid state physics, and material, physics of material. So actually, I believe that the structural analysis is mainly based on physics. It it just physics. If you understand physics, the structural analysis should not be difficult for you. So here, for example, this building is being built, being constructed. Each element of this building, if we take the beams, for example, what are different forces acting on each element of this building, and how they these forces, how the element of this building will react to the forces applied. Okay, will it be stable or will not? It will not be stable. So all the forces acting on this structure are needed to analyze this structure. Here as well, for example, if you take this bridge being constructed, what is the forces acting on, for example, on the slab, for example, on the column, okay, on the beam, this beam, for example, this is beam. What are the forces acting on the beam, and what are the consequences of those forces acting on the beam? Here, for example, we can talk about these cables, this cable of this bridge. These cables are receiving tension. So each cable should be designed according to the tension, the force it will support. Okay. Why is it this type of cable? The material of the cable also will be selected based on the type of force the cable will support. Here also another example. In this water tank, we have water inside. What will be the pressure of the water on the structure inside? According to the amount of the pressure, we can design the structure. A dam here we have. So this side of this dam, the upstream, water is acting on the dam. What is the pressure at each point of this dam? Okay, what is the pressure? So the thing is, a lot of forces are acting on the structure, and each element of the structure will react to the forces differently. So we need to know the forces acting and what are the internal stress caused by these force, the external forces, and what are the deformation, what are the displacement caused by external forces. Okay, so all this, if you continue watching this program, you will understand how to design all this using structural analysis. But this first section, this first part of this structural analysis is just introduction of what only this first part will not allow you to design this. Okay. So this is what or where we can use the structural analysis. What about now mechanical action acting on geotechnical structures? So as I said, the beginning, mechanical action, when we say mechanical action, it's like forces and moment acting on our building and civil structures. So what are different structures? For example, if I take these three, this is a dam, this is a bridge, this is a house building. So what are different actions, mechanical action acting on these structures? Okay, we have a type of action called permanent action that include the weight of the structure itself, the weight. I think you know that, everyone know that. Temperature, for example, temperature is permanent action because, as you know, some structure are there are dilatation due to temperature. We have also operating actions, not expenses. Okay, I need to correct this. Operating actions, operating forces. For example, on this bridge, when cars are moving on this bridge, this is operating actions. And here also, for example, this sofa or this car or people are coming in, going out, this is operating action. We have also wind effect. The effect of wind, especially for this kind of high rise structure, the effect of wind is to be considered in the calculation. If you miss it, it will be disaster. You have to consider the effect of wind as a force mechanical action acting on the structure. And we have also accidental actions. For example, if a car hit this column, we have to consider this kind of accidental action. Or for example, this area, mountainous area, we can have, for example, landslide that can hit the bridge. Okay. So there are several actions. I think we will come back on this action later. But just to make a introduction on different type of action that may act on any structure built. So these mechanical action, they are sometimes inducing some effect on structure. Okay, what are the consequences of this action? They can provoke movement. They can cause movement of some part of the structure. They can also keep it in balance. Yes, indeed, some actions are bringing stability to the structure. But some action also distort the structure. So these are the main three effects of mechanical actions acting on your structure. If we take, for example, any system, material system composed of solid connected to each other, the connection between them here will be internal connection, but also the support to reference support are considered as external connection. So the building or any structure is connected to each other. They are connected, the element of the structure are connected to each other, but connected to the soil also, for example. Okay, if we take this, for example, we have a lot of steel element, steel bars that are connected to each other. So we take this one is a beam, for example, and this one is column. So we have here a connection between these two. We can consider this as internal connection. And this column, for example, is connected to the ground. This can be considered as external connection. So These connections sometimes are generally unknown, and sometimes they are too many, overabundant. Okay, let's go now to object of static. Static, what is static? Static, I'm not sure if translation is right, but static is study of mechanical action exerted on non-deformable body. When I say body, it means non-deformable, for example, structures in equilibrium. Okay, so the hypotheses of static are as follows. There are three main hypotheses. The bodies, the structure, are considered only subject to forces, moment, and reaction support. Okay, the support reactions. Only these three are acting on the structures. Okay, this is one. Number two, this structure, this body are ideal. Ideal, it means they are non-deformable. They are rigid, technically same, and they are capable of supporting very important loads. Okay, at absolutely any magnitude. So this is the second hypothesis. And only the balance of the structure under the action of forces is studied. So these are the three hypotheses considered in the static. Okay. And when I say RDM here, RDM is just material resistance. Okay, material resistance. So static is just part of material resistance. The resistance of material studies the effect produced by forces which stress the construction and determine the condition what the different part of this construction must feel. Okay, so that it can support these forces. These conditions are, the first condition is each part of your construction, each part of the building or structure must not be mobile, okay, except the elastic deformation. It should be fixed so that it has a defined position, okay? So it means each part of the building, of the structure, must be linked to the other parts and to the ground so that the position of the part is well defined. It should not move anyhow. So each part of the construction must also not break, okay? It should be rigid. It should not be fragile. It should not be deteriorated. And that means that the stress supported by the material must not be too high. If you apply too much stress on the material, so it will break. This is the second condition. The third one, the balance of all the element of your structure, beam, column, everything, slab, of the construction, all of them, they should be stable. These are the three conditions, okay? Static. So if you want to study a structure in, if you want to study a structure in resistance, material resistance, I will change this later. It means just material resistance, okay? So you should first check the static. These are the steps you should follow. If you want to study a structure, you want to do the analysis of a structure. So start by the static phase, the balance of external forces. And the external forces, we have talked about external forces, permanent forces or variable forces, wind, for example. Okay. After that, you now check the resistance of your structure. The resistance, it means you check the internal forces that might cause the external forces. That means the shearing forces, shear force, normal force, or bending moment. You should check. Rigidity now. What is the rigidity? If you study this shear force, normal force, and bending moment, it will allow you to find the deformation and displacement. That means deflection and displacement. Okay, so you will judge, because if the displacement deformation is high, it means your structure is not rigid at all. So the rigidity comes after checking these internal forces. Okay, then you check the stability or instability by studying the equilibrium condition linked to the characteristic of the material, not matter, actually, the material. Okay. So this is how it goes. You do the design, means you are in the office, you do everything, drawing, calculation, all the design. And after that, the next step is construction. You build this structure. For example, here is a bridge. Okay, step by step. If we zoom, this is the slab, for example, and here the pier, bridge pier. Okay, and we have at the last the usage. So it means after finishing building also, you have still to keep monitoring the structure to see if the limit displacement or what you have done as design, if it is really good or not good, and improve your experience in this thing. Just steps. Okay. And we'll talk about both aspect of the study. In structural calculation, there are two aspects. If you want to do the analysis, two aspects. The first one is verification, the structural verification. The second one, design of the structure. Okay. These are the two main aspects. We will give detail of each of them. First, the verification, structural verification. So to do the structural verification, we have to use what we know first. And what should we know? And what do we know? Or what can we know easily? We can know the forces acting on our structure. Absolutely everything we can know these forces. Okay. So we can also know dimension of any section of the structure. We can know dimensions. Okay. So if we know this, we can know also the material. Is it, for example, if we are talking about a bridge, the bridge, is it made of steel or concrete? Okay. So these three point actions, dimension, and material is what we should know. And we can know that easily because these are almost physical. They are visible. No need to calculate this. Okay. So if we know that, maybe the actions you need to calculate. For example, if you are designing a bridge, you should know the action of the cars running on the bridge. Okay, you should calculate the action of the wind. You should calculate the action of accidental action, for example, landslide hitting your bridge piers. Okay, but dimension of the bridge, that is easy to know. The material used, concrete, or when we say material here, it means actually the mechanical property of this material. What is, for example, the Young modulus of this material. Okay. Then if we know these three, we can go to calculate internal forces and displacements. Okay. Internal forces means sharing forces, bending moment. Okay. Normal forces. Okay. And after that, we can check if the requirement are respected. For example, if the design is asking that displacement should be less than maybe 2 millimeter or 5 millimeter, we can check after knowing these forces and calculating the internal forces. Means internal forces here means internal stresses. So if we know the stresses, we can calculate the stresses and displacement. We can then check, because this is the verification step. We can then check these displacement are then less than what is required, the limit imposed for this project or not. Okay. So here is an example of the bridge, a bridge, for example. We can see here the slab here. If you decide to study this slab, for example, you check all the forces acting. Means this is step one. All the forces acting on this bridge, wind, self-weight, okay, everything. And then dimensions. We know the dimension, for example, of the slab. We know the thickness, everything. And the material, maybe this one is concrete. Then you can calculate internal forces, means internal stresses. Here is an example. So if we consider that this is, for example, this slab, this or let's say beam, okay? We can study this and see what is displacement or moment, bending moment or shearing force at each point of this beam, for example. Each point, we can know the internal stress here or here or here, and we can know the displacement at each point. Then knowing that, we know that, okay, with these forces, acting forces, in this dimension, in this material, this concrete or steel or any other material, here is the displacement we will obtain this point, at this point, and at this point. And with the displacement calculated, obtained after calculation, we compare the obtained calculation, calculated displacement with what the requirement is telling us. If you calculate and the displacement in your calculation is, for example, 3 millimeters, and the requirement is saying maximum is 5 millimeters, so it means your design is safe, calculation is safe somehow. So this is first step, first aspect. The second aspect is the design itself. So that means you have to know the actions, means external forces, the degree of security to be achieved. Degree of security to be achieved. Okay? So if you know that, you can determine the optimal choice. You can choose the dimension. Are this dimension appropriate? You can choose the material. The bridge, should it be in concrete? Should it be steel? Which material will you choose to build your bridge, for example? Here I'm talking about bridge, but it can be anything, any other structure, okay? It's not only bridge. And then the design process. First, the pre-project. This means like feasibility study. And after that, verification and iteration. And this making like the experience of the engineers or engineer. So I think that all. This is just introduction. We didn't start anything yet, but by the end of this first part of this structural analysis, I hope you will learn a lot of things and you will be able to design this kind of, how to say, this kind of structure at the end. But this, just follow this program and you will be able. This is just number one, the first part. And this first part has 5 chapters, okay? So at least two more parts will follow this part, okay? So we will just stop here. Thank you very much for your time and see you next time. Thank you very much.